Hi, in the previous lecture we have been talking about how to insert into a heap data structure, and we have been discussing that how to implement this fix up method in order to make sure that the heap properties are not violated after the insertion. In this given lecture we are going to talk about merge sort. Okay, why is it good? The aim of merge sort is to make sure that we are going to end up with the numerical ordering for integers or alphabetical ordering for strings and characters. So we will have the heap sort with the self, okay, and we just have to iterate through. So for I in the range 0 and self dot current position, we just have to get the maximum item. What's the maximum item? The maximum item is the heap with the 0 index. This is what we have been discussing, that the root node is going to be the maximum value for maximum heap, okay, the minimum value for minimum heap, but here we are discussing maximum heap, okay. Then we have to swap that given item with the last item. So this is what we have been discussing, that we keep swapping the root node with the last item, and we keep considering that given item to be already sorted. So in this case we swap the root node with 5 and we consider this node to be already sorted, so we don't have to consider it anymore. And then we have to make sure that it's going to be a valid heap. It's not a valid heap because the maximum item is not at the root node. So that's why in this case we are going to implement not a fix up but a fix down method, and we are going to start with the root node and we have to make sure that the heap is going to be valid. So we have to reconstruct the heap. Okay, we are able to do it in logarithmic, so ordo log n running time. After that we keep swapping the root node again with the last item and we consider that item to be sorted too. So in this case we do not consider 210 and we don't consider 100. Again we have to make sure it's going to be a valid heap, so we have to swap them and so on. This is how heap sort works. So we print out that given number and we keep printing out the temporary variable. Then we keep swapping it with the last item. So the 0 is going to be the last item, so the self heap with the self current position minus I. It's very important that we have to make sure that it's going to be minus I. We keep considering fewer and fewer items, okay? And of course we have to set the self.heap with the self.current position minus I to be equals to the temp. Okay, so this is how we swap them. And then we have to fix down starting with the root node. We just have to consider as many items as the current position minus I minus 1, because indices starts with 0. So it's very crucial that we have to consider fewer and fewer items. So that's why this I is going to be 0, then 1, 2 and 3, and that's why we are going to consider fewer and fewer items. So this fix down method is the one we are going to implement in the next lecture. Thanks for watching.